In this video we're going to look at the complex problems for volume, predominantly concentrating on a frustum or a frustrum of a cone. And a frustrum of a cone is essentially a cone which has had its top removed. So it's a large cone minus a small cone. So example 37, a cone of height 15 centimeters and radius 10 has a cone of height 6 centimeters removed. Find its volume and surface area. So what we've got is this shape here where we've got a large cone with a perpendicular height of 15 and radius 10, and the small cone with an unknown radius but a height 6. Now what we do know, if we could think about it in terms of fractions, is that the small cone is 6/15 of the large cone. So if we do 6/15 of 10, that will give us the small radius, and that works out to be 4. So the small radius is going to be 4. What we need to do as well is work out the slant height. Now if we work out for the large triangle, what we've got is r squared plus h squared equals l squared, where r is the radius, h is the perpendicular height, and l is the slant, and that's coming from Pythagoras' theorem of a squared plus b squared equals c squared, where c is the hypotenuse. So then we get 10 squared plus 15 squared equals l squared. So that's 325 equals l squared. So l works out to be 18.0278. And if that's the slant length of the large cone, then the slant length of the smaller cone is going to be the same. So it's going to be 6/15. So the same fraction of 18.024 or 0278, which is 7.2111. So we've got all the measurements that we need. So if we're looking for the volume of the big cone, it's going to be a third the base area, so a third times pi r squared times h, which is a third times pi times r squared, so that's 10 squared times 15. So that's 157.0796. Now we need to work out the volume of the small now, and that's a third times pi r squared times h again, which is a third times pi times 4 squared times 6, which is 100.5310. So the volume of the frustum is the difference between the big and the small, and because the top has been removed, it's just the bottom volume that we're looking for. That's going to be 56.55 centimeters cubed to 2 decimal places. Now to work out the surface area of the frustum, we're going to have to do the large surface area of the cone and the small one. So the surface area of the big, so that's pi RL, which is pi times 10 times 18.0278, which is 566.360. Surface area of the small cone, again, it's going to be pi RL, so it's going to be pi times 4 times 7.2111, which is 90.617. So the surface area of the frustum, which is the difference in those two areas, is going to be 475.74 squared centimeters. But that's only the curved surface area, so that's only the bit around the outside. What we need to do is we've got a circle on the top and a circle on the bottom. So we need to work out the area of the circles. So they're pi r squared. So that's going to be pi times 4 squared plus pi times 10 squared. And that works out to be 364.42 squared centimetres. So the total surface area is 840.2 squared centimetres to 1 decimal place. A segment of a circle is the area above or below a chord, and because the blue part of the circle here is greater than half of it, it's called a major, and the orange one is a minor because it's less than half. To work out the area of a segment, we work out the area of the sector, and to do that, remember that was the angle fraction, so theta over 360 times pi r squared, and then we need to subtract the area of the triangle. And a nice formula that we can use for that is a half r squared sine theta, where theta is the angle, the full angle in the segment. So example, find the minor segment area, which is a radius of 15 centimetres and is subtended by an angle of 100 degrees. So we've drawn the circle and we've marked on the radius, and that's going to be 15, and the other radius is 15. The angle is 100. So what we want to do is find the minor segment area, so this bit in here. So segment area is sector minus triangle, which is 100 over 360 times pi times 15 squared minus a half times 15 squared sine 100. 196.35 minus 110.79, and that gives us an area of 85.56 squared centimetres. So if we want to work out the frustum, it's the big cone minus the wee cone. And we already know the frustum, so if we can work out the volume of the big cone, then if we take away the frustum, we'll get that. So volume big is going to be a third times the base area, so that's pi r squared, times the perpendicular height, which is a third times pi times 3.5 squared times 8. That works out to be 102.62 cubic centimetres. The volume of the small then is going to be the volume of the big minus the frustum. So that's 102.62 minus 92, which is 10.62 cubic centimetres. Example 40, find the volume and curved surface area of a frustum, which is comprised of a cone with a height of 4 and radius 3 removed from a cone of height 12. So what we've got is this cone, and the full height is 12 and the smaller height is 4 and the smaller radius is 3, and we've got an unknown radius for the large cone. But what we can see is that the small height is a third of 12, so 12 divided by 4 is 3, so that means that the large radius is going to be 3 times the size of the small one, which is going to be 9, so the large radius is 9. From there then, we can work out the volume of the frustum. So volume big is going to be a third times the base area, so pi times 9 squared times the perpendicular height of 12, which works out as 1017.876. Volume of the small cone, so a third the base area, so a third times pi times 3 squared times 4, which is 37.699. So the volume of the frustum is going to be the difference in those two volumes, which is 980.18 cubic centimeters. Now, to work out the curved surface area, what we need to do is work out the slanty lengths. So if we look at the small triangle, which has a base length of 3 and a height of 4, then the slant L using Pythagoras' theorem is going to be 3 squared plus 4 squared equals L squared. 25 equals L squared, so L equals 5. And because we know the large cone is 3 times as big as the small cone, then the large slant is going to be 15 centimeters. So the surface area of the big, which is pi RL, so pi times the radius times the slant, which is pi times 9 times 15, which is 424.115. Surface area small, pi RL again, only this time it's pi times 3 times 5, which is 47.124. So the curved surface area of the frustum is the difference between our surface areas, which is 376.99 squared centimeters.